Okay, so I'm going to do the 4-1, number 1. And it says provide the following statements assuming n is natural number. So if n squared is odd, then n is odd. If n squared is even, then n is even. So I wrote it out like this just so it's easier to understand. So if we have all natural numbers, which is 1, 2, 3, 4, 5, 6, 7, 8, and then we're just going to go up to 9 because it's easier, but you would keep going because natural numbers are all of them. So the odd numbers of this are 1, 3, 5, 7, and 9. And the even numbers of this are 2, 4, 6, and 8. So these n numbers are just going to be all the numbers combined together. So you just do 1, 2, 3, 4, 5, 6, 7, 8, and 9. That was terrible, but okay. So then the n squared, you would just take 1 squared, which basically means 1 times 1, and that equals 1. And then you do 2 squared, which is 2 times 2, and that equals 4. And then you would do 3 squared, which is 3 times 3 equals 9. And then you would do 4 squared, 4 times 4 equals 16. 5 squared, 25. I promise we're actually getting to the point. We just gotta do all the work before we can get to the point, actually. 36, 7 squared, which is 7 times 7, equals 49. 8 squared, 8 times 8, which equals 64. 9 squared is 9 times 9, equals 81. Okay, so now that we have that done, let's look at this. So, if 1 is odd, the n squared is odd. If we have 3, which is odd, we go down here, 9 is also odd. So that proves if n squared is odd, then n is odd. So now let's try and prove if n squared is even, then n is even. 2 is even. 2 squared is 4, which is also even. 4 squared equals 4 times 4, which is 16, which is also even. So through this we have proved that if n squared is odd, then n is odd, and if n squared is even, then n is even.